Here is an interesting looking problem. Let me label the masses. So this is the mass M1, this is the mass M2, this is the mass M3, M4, M5, M6. So we go about our usual business and we set down the distances. So basically this distance of the mass M1 from this rear support is x1. This distance happens to be equal to x2. This distance happens to be equal to x3. So let me label these three first. This is x1, this is x2, and this is x3. Now for the mass M4, this distance happens to be equal to x4. For the mass M5, this distance happens to be equal to x5, and for the mass M6, this distance happens to be equal to x6. So we have to measure all distances from rigid supports. The rigid supports may be the same rigid support or it may be different rigid support. If it is a different rigid support, it does not matter because distance between and the displacement vector or the position vector of one rigid support with respect to another rigid support is going to remain fixed or the same. So on double differentiating in order to get accelerations, or in some questions on differentiating in order to get the relation between the velocities, we still get 0 because the derivative of a constant position vector is going to come out to be 0. So let me label these. So this is x4, this is x5, and this happens to be x6. So we have now labeled all the masses. Now what remains is to understand how many independent pulleys are there. So you can see that this is one independent pulley that is moving, this is another independent pulley that is moving. So these two pulleys need to be accounted for. So the distance of this pulley from a rigid support will be, let's label it as xp4 and this one as xp5. So let me label this as xp4 and this is xp5. Let's understand what other pulleys are moving. There are two pulleys over here that are moving. So this is one pulley that is moving and this is another pulley that is moving. So the distance of this particular pulley is going to be equal to xp1 for this pulley, and for the second moving pulley we are going to take the distance from the upper rigid support, and this we are going to label as xp2. So I think we have covered all the moving parts. Yeah, so we can now easily solve this question. So this is the length of the string, let's say L1. So this much part happens to be equal to x1 minus xp1 clearly, and this much part happens to be equal to x2 minus xp1. So the first thing that we can write down over here is x1 minus xp1 plus x2 minus xp1 equal to length of string 1. Okay, now for the length of string 2, it is apparent that this much part is going to be given as xp1 minus this much part, which is xp2, and this much part is going to be given as x3 minus xp2. So the second equation that I need to write down is xp1 minus xp2 plus x3 minus xp2. So this is length of string 2. For the mass M4, we need to understand that this particular part of the string is constant in length. So this is, let's say, D. This is the D part. So there is a string that is coming like this. See, this much string. This is having xp2 as the length over here, d as the length over here. Here the length is x4 and here the length is x4 minus xp4, and here the length is x5 minus xp4. So for this interesting string, we'll have to write down x2, xp2 is the length that comes from the left hand side vertical part. So this is xp2. Now then d, I'll have to add d with it, plus d. So we have reached from here till here, we have reached. Then we go down, that is x4 simply. Then we go up like this. This much part of the length of the string happens to be x4 minus xp4 plus x4 minus xp4, and then this much part of the length of the string happens to be equal to x5 minus xp4 plus x5 minus xp4. So this happens to be L3. So this is the length of this particular string that goes like this string. Okay, now let us say we take the distance between these two rigid supports as d dash. Let's say this distance is d dash. Why do we need this distance? Because now that we are going to do the analysis of this particular mass m5 and this particular string, then we need to understand that this part of the length of the string is nothing but xp4 minus xp5, and this part is nothing but d dash minus xp5. So this is xp4 minus xp5, and this part is d dash minus xp5, because xp5 happens to be this much part. So xp4 minus xp5 plus d dash minus xp5. All these constants like d and d dash, they get differentiated out to be 0 while finding velocities or accelerations. So this is L4, the length of string 4. So this is what we did, and now we get the fifth and the final string, for which we can clearly write down xp5 plus x6, xp5 plus x6. This is going to be length of string 5. So it is xp5 plus x6 is equal to length of string 5. So these are the 5 equations which on double differentiating will give us the relation between the acceleration. So on double differentiating the first equation, we get a1 plus a2 minus 2 times ap1 equal to 0. This is equation 1. Let's say on double differentiating this, we get ap1 plus a3 minus 2 times ap2 equal to 0. So this is equation 2. On double differentiating this, we get 2 times a4 plus ap2 minus 2 times ap4. So that covers this term, this term, this term, this term goes away to be 0, this term, and what we are left with is plus a5 equal to 0. So this is equation number 3 that we get. On double differentiating this L4 equation, we get ap4 minus 2 times ap5 equal to 0. So this is the fourth equation. On double differentiating the final equation, we get AP5 plus A6 equal to 0. So this is the fifth equation. Let us analyze and write down what are the unknowns. So the unknowns till now are A1, A2, A3, A4, A5, AP1, AP2, AP4, AP5. So you got 5 unknowns and then additionally 4. So basically till now we have written down total 9 unknowns. Now let us understand what is happening with the tensions. So let us fix one tension and let us find out what's happening to the other tensions. So let us say we take the tension in this string to be T. So this also is T. This is 2T. This happens to be 2T as well. This is going to be 4T. So this 4T comes over here. This is 4T. So this happens to be 8T. This is 4T itself. This is also 4T. This is also 4T. As long as the string is the same, the tension is the same as well. And then this happens to be 8T over here. And then this happens to be 8T as well. So this happens to be 16T. So these are the tensions in the string. Now let us choose a direction for the acceleration of all the masses. So for the mass M1, I am choosing A1 as the away going direction from the rigid support. So this is A2, this is A3, this is A4, this is A5, and for this we'll have to write down a counterintuitive equation with A6 as the away going direction. So let us write down the 6 equations for all the 6 masses. So those equations come out to be like so. For the mass M1, we may write down M1G minus T is equal to M1A1. So this is our equation number 7. For the mass M2, we may write down M2G minus T is equal to M2A2. This is our equation number 8. For the mass M3, we may write down M3G minus 2T is equal to M3A3. This is our equation number 9. So for the mass M4, we may write down M4G minus 8T is equal to M4A4. This is our equation number 10. For the mass M5, we may write down M5G minus 4T is equal to M5A5. This is equation number 'I have missed equation number 6 actually. So I'll label the next one as equation number 6, no problem. So this is the equation for the mass M5. M5G minus 4T is equal to M5A5, and for the mass M6 we'll have to write down a counterintuitive equation minus 16T. That is the force in the direction of A6. Minus 16T is equal to M6A6. So let's say this is equation number 6. So these are the 5 equations: 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 equations have been mentioned over here. Let's look at the unknowns. So the 5 accelerations of the masses 1, 2, 3, 4, 5 are the 5 unknowns, and then of course for the mass 6th mass also, A6 is also an unknown. So basically you have got here a set of 10 unknowns, A1 to A6 and AP1, AP2, AP4 and AP5, and then we have got tension as the last unknown. So T. So you have got 11 equation, 11 unknowns basically. So solving these particular 11 equations, you can get down the value of all the unknowns and solve this particular system. So this was a pretty interesting problem to deal with.